Hello, hi friends. Welcome to VXL Basics. Today we are going to see about FSM state machine implementation in VerilogHDL. For that we are taking example which is shown in the figure. Uh, FSM is nothing but finite state machine which we will implement using case statement. So here we will see the syntax of case statement in Verilog. Coming to the figure, there we are having two states actually. So the binary representation of the state, each state will be will have single bit actually, since we are having only two states. So 0 and 1 we can use. If there is more than two states, for example, if we have five states in the state machine, we need to use 3-bit value for the each state, which is nothing but 2 power 3. So we only but 2 power 3 in the sense that the totally each statement, but in our implementation we required only 5 states, in the sense we need to have one default state which will required for the remaining states. So unused value of the state value. So if coming to the figure, so yes, there are two states, S0 and S1. So initial state is nothing but S0. There we will sample the input value X with respect to the passage of the clock. If that is 0, it will remains in the S0 state and the output will be 0. If X equal to 1, it will go to the next state S1 and the output will be Z equal to 1. In S1 state, X will be sampled at the passage of the clock. If X equal to 0, it will remains in the S1 state and output will be 1. If X equal to 1, it will go to the S0 and output will be Z equal to 0. So like this state transmission will happen in this particular state machine. For now we are implement this state machine in the Verilog. For that we need to take reset clock X as the input, Z is the output. For declaring the state machine value, we will declare that as a local parameter. Local param is nothing but a constant value which we can use in this module. Here we are having only two states, S0 and S1. So we are declaring both of them as a local parameter. S0, the value of the S0 is 0, S1 is 1 actually. And then we will use two states, present state and next state, as a register, since we are going to use them within the always block. So first always block, if you see, with respect to the passage of the clock or with respect to the passage of the reset, it will check the reset value. If reset is 1, and then state machine F0 will be assigned to the present state, else next state value will be assigned to the present state. Coming to the next always block, where we are implementing the combination logic of this particular state machine. Here we are using the case statement to implement the FSM. So the input for the case statement here is present state. We will check the present state, and in that particular present state we will monitor the X value. With respect to the X value, we will change the state, or we will remain in the same state, and we will change the output Z value. So here we have only two state S0. So if you take the S0 state, I am checking the X input whether it is 1 or 0. So if it is 1, next state will be S1, Z will be 1. Else this will remain in the same state S0 and the output Z will be 0. Coming to the state S1. Thereafter I will monitor the input X equal to 1 or not. If it is 1, next state will be S0, output will be 0. Else this next state will be remain in S1 itself, and the output is equal to 1. And I am using default state also. If the state state has 3 bits of value, right? For example, if we record 5 state mission, Then we need to represent each state machine in 3 bits actually. In that case, 2 power 8 combination, 2 power 3 combination, which is nothing but 8 combination we will have actually. In that 8 combinations, we are using only 5 values. The remaining 3 will comes under this default value. There we will assign the initialized state itself. And the syntax for this case statement is nothing but case and expression. Each state will have the own logic and then default statement, and then end case should end the case statement. If this is the implementation of FSM in VerilogHDL. Please like, share, and subscribe this channel for the more videos. Thank you. Bye.